everyone. So I wanted to formalize some of the things about negative exponents that we talked about today during your stand and talk. And so today we talked about the fact that we've been dealing with exponents. And when we're dealing with exponents, I like to think of it as factors of a specific number. So for example, 2 to the 5 would be 5 factors of the number 2. And factors are numbers that are multiplied. So we knew that 2 to the 5 could be written as 2 times 2 times 2 times 2 times 2, which is 32. And then what you guys said you noticed was that as the power got smaller, the value got smaller. And that makes sense because I have less factors. So 2 to the 4 was 16. So you recognize that the value got smaller. And then we discussed what would happen here. So 1 factor of 2 gave me 2. But what did 2 to the 0 power give me? That means no factors of 2. And we said that that value actually gave me the number 1. And the reason we came up with that is because each time what many of you noticed is that you were dividing the number by 2. And I love that you noticed that each time you were moving down by a factor, you were dividing that factor away, getting rid of it. So then we realized that 2 to the 0 power was 1. But what about 2 to the negative 1? How can we have negative factors? So if you think of the idea of what we were doing to each number, you guys recognize that then this would become 1 divided by 2, and 1 divided by 4, and 1 divided by 8, and 1 divided by 16, and 1 divided by 32. And you recognize that as the factors became more negative, the numbers actually got smaller. Well, I want to talk about this idea and this negative exponent a little bit more. So negative exponents are things that exist. And I like to think about negative exponents as making like this number, it made it smaller. It didn't make the number negative because negative exponents don't make the number negative. Well, let's compare some things. We've learned about dividing exponents. So let's pretend that I give you x squared all over x to the 5th. If we use the rule that we came up with with exponents, then you guys recognize that you would bring the smaller to the larger and subtract, right? Well, the smaller is 2, and you'd get x to the 5. So that would give me x cubed, right? All right. And the reason we came up with that rule is because we realized that x squared is 2 factors of x. And x to the 5 is 5 factors of x. And so, again, we've got these x's would cancel, these x's would cancel. We'd have to leave a placeholder 1 in the numerator, so we would get 1 over x cubed. But let's pretend you didn't follow the rule, bring the smaller to the larger and subtract. Let's pretend you just subtracted. Then wouldn't you just subtract the 2 and the 5 and get 2 minus 5? And wouldn't that give me x to the negative 3? Well, and that is actually what can happen. If you don't follow that rule we came up with of bringing the smaller exponent to the larger, then you'll get x to the negative 3. But we just proved 2 different ways that it's 1 all over x to the 3. So that's one of the laws of negative exponents. If you have a to the negative 1, any number or variable raised to the negative 1 power, we can rewrite it as 1 all over a to the 1. And remember, that's the phantom 1, so we don't have to write it. The same is true, however, with 1 over a to the negative 1 power. That actually basically means that we're making the number a larger number. And if you want to think of it like this, think of it as a to the 0, because we know a to the 0 is 1 all over a to the negative 1. And we'd bring the smaller to the larger and subtract. So we get a to the 0 minus negative 1, which would give me a. So that law says that if you have 1 all over a to the negative 1, that it's just going to become a. So these are the 2 laws, and I think I've hopefully made it clear as to why those 2 laws exist the way they do. Thanks. Have a great day.